notation and interval notation and kind of make sure everybody remembers that. So I'm going to put a few problems up here for us to practice. In this class, we will write everything in interval notation. And really, from here on out, any math class you take, that is kind of the standard, using that interval notation. So remember, interval is giving you a starting and a stopping point on a number line. So it's always going left to right, small to large. You have the option of parentheses or square brackets. What does a parenthesis mean? Not equal to. And a square bracket means equal to. So that's why a couple people, like on their quiz, they were writing like answers like this, and I would write over it, make it a solution set, because those are two different things. A solution set means only 1 and 4. When you write it with those parentheses, now that we know interval notation, that's saying everything between 1 and 4, which is two different things. So we have to kind of be careful on our notation. So this one, if I'm looking at that, this says 1 is less than or equal to x is less than or equal to 3. So my interval notation, the equal to tells me I get a bracket. It starts at 1, comma, ends at 3, also an equal to, so bracket. Always goes small to large. No variables are involved in this. You just do starting and ending point. So what would we write for B? How would we write B? Parenthesis, -4, comma 0. Both of them were not equal to, so they both get parentheses. All right, C. X is greater than 5. So interval notation, we have to have a starting and a stopping point. Where do we start? Everything bigger than 5. So we start at 5, but it's not equal to, so it's a parenthesis. Comma, where does it end? Infinity. Remember, infinity is not a specific number, so it always gets a parenthesis. You cannot be equal to infinity. Last one, if I said x is less than or equal to 1, what would we write? Negative infinity with a parenthesis, union, or comma 1 with a bracket. Right, is this stuff familiar so far? Okay. Here's the other way. If I give you the interval, can you tell me what that is as an inequality? So if I say bracket 1, comma 4 with a parenthesis, what would that mean? Come on, you guys are writing it down. Tell me. Good. The 1 had a bracket, so it gets an equal to. 4 did not. B. 2 to infinity. What does that mean? X is greater than 2. C. If I said 2 to 3 with brackets. Perfect. And final one, negative infinity to negative 3 with parentheses. All right, good. So we can go back and forth between these notations. I wasn't practicing it. Could you guys like draw a number line and graph these on a number line? Okay. When you did number lines last year in Mrs. Keller's class, did she do open and closed circles on her number line? Okay. The only difference is I kind of switch, instead of doing open and closed circles, we do the parenthesis or bracket on our number line as well. So I'll show you those instead. That's just kind of a common notation in our textbook, so we'll go ahead and make that switch. So let's let's solve a problem, and I don't need to do that. Show you the graph, just to kind of clarify what I mean. So if I said 3x minus 1 is greater than or equal to 3 plus x. All right, things to remember. Solving an inequality is just like solving an equation, except, yes, if you multiply or divide by a negative, it flips your inequality. So on this one, I could subtract over my x. I'm going to go ahead and add my 1 in the same step. So I get 2x is greater than or equal to 4. Divide by 2, so x is greater than or equal to 2. But I'm going to want my answer in interval notation, so how are we going to write that? Bracket 2 to infinity. Okay, in terms of a graph, I am not super picky. If you are drawing a graph on your homework, because you're big kids now, so I don't usually print graph paper and number lines for you. You have to draw your own. You're welcome. I'm not going to make you start every number line at 0. You can give me any snippet of a number line you want. So, you know, it doesn't have to be the same, centered at 0 every time. So if you just have enough numbers on here, 2 to infinity, that would be a closed circle is what you're used to, but we're just going to do a square bracket to infinity. Some people like to draw it above their number line a little bit so it's easier to read. That's fine. I don't care. Your bracket will face the same way it did in our interval notation. So it's going to face the way your line extends. Does that make sense? So you're never going to like draw something like this. Your bracket faces your shading. All right. So can we solve a linear equation like that? No problems? Okay. Let's try this one. This is what we call a compound inequality. It's got more than one in it. When you solve this, it's just like solving an equation, but whatever you do to one piece, you have to do to all three, the left, right, and middle. So if I'm trying to get x by itself, where would we begin? Multiply everything by 4. Left, right, and middle. Okay, in the middle, those 4's cancel, so we have negative 12 less than 2x minus 1 less than 0. Add 1 to everything. Divide by 2, so negative 11 halves is less than x is less than 1. What would that be as an interval? Parentheses because nothing had an equal to. If you are going to graph this, negative 11 halves, that's negative 5.5. Okay, so you could make me a number line here. I'm not really picky if you don't label every single number. As long as I can tell what you're counting by, that's fine. So negative 11 halves, that's negative 5.5. Positive 1 half. Everything in between. So far, so good? Why don't you guys try this problem? So if we subtract our 8, negative 10 is less than negative 2x, is less than or equal to negative 9. When I divide by negative 2, what happens? Switches all of my signs. Okay, so this would be 5 is greater than x is greater than or equal to 9 halves, or 4.5. When you go to write your interval notation, it has to go small to large. If you wanted to flip this around, this is the same thing as saying 9 halves is less than or equal to x is less than 5. So my interval would be bracket on the 9 halves, comma, 5 with a parenthesis. Number line, you don't have to make a very big one. 9 halves starts where? Yeah. So 9 halves is 4.5, ends at 5. So it's just a very short little solution set. Do we need more problems like this? Okay. So the next thing I want to talk about is quadratic inequalities. And that does kind of change things a little bit. So we're going to take a look at some of these. This will be the last type of problem that we do today. And then tomorrow we're going to look at fractions with our inequalities. And so those of you that have softball, what time do you get dismissed? The assignment will be at the end of the video. We'll see if they don't make an announcement soon. I'll check. All right. If this were an equation, what would you do first? Factor it, right? You get it equal to 0, and then you factor. So this would be x minus 4, x plus 3 is less than 0. Okay, if this were an equal to, at this point you would tell me x is what? 4 and negative 3. Now, you cannot just tell me x is less than 4 and x is less than negative 3. Because if x is smaller than both of those, okay, so maybe if x is negative 5, isn't that smaller than both? Negative 5 minus 4, that's a negative number. Negative 5 plus 3 is negative. When you multiply two negatives, what happens? It's a positive. Is it still less than 0? No. Okay, so we have to have a different strategy here. There are a couple different ways. We haven't really talked about the graphs of quadratics yet. You have in the past. But we're also going to be looking at some uglier ones tomorrow where we don't know what the graph looks like. So I'm going to make what's called a sign line to help me. Hey, it's Mrs. Reichold. Am I supposed to dismiss softball? Okay, they're telling me they got out at 2:30. Okay. Okay, so what do you want me to do? Okay, all right. Okay, sounds good. Thanks. Bye. Well, Miss Washington knows nothing about it, but I guess go ahead. Okay, so we are going to ask ourselves what makes these things equal 0. So we already said this is 4 and this is negative 3, right? These are going to be two numbers on our number line. Now, we're going to put them on like a true number line. So smaller one on the left, bigger one on the right. So we're putting them in order. Now, what we're going to do is pick test points. Essentially what this means is if we graph it, those are the two places where our graph would hit the x-axis. Okay, if that's the only place where it touches, then it's either above or below in the others, right? Positive is above, negative is below. So let's just make up some test numbers. So I just need any number less than negative 3. Doesn't matter what number. Is negative 1 smaller than negative 100? Oh, negative 100. I was going with negative 4, but you know, negative 100, we can go for it. Something between negative 3 and positive 4?
0.
0, my favorite. All right, and then something bigger than 4. Okay. We do not care what we actually get when we plug these in. We only care if it's positive or negative, if it's above or below the axis, okay? Because this is where it hits the x-axis, so I'm just trying to figure out, before that, was my graph up here or was my graph down here? So if I plug in negative 100, negative 100 minus 4, is that a positive or a negative number?
Softball players can be released at this time. Girls softball can be released at this time.
Is negative 100 plus 3 positive or negative? If you multiply two negative numbers, what kind of answer do you get? Positive. So that means anything smaller than negative 3 that I might plug in would make this inequality positive. Are you guys all with me here? Okay, now we plug in our 0. So 0 minus 4 is negative. 0 plus 3 is positive. If you take a negative times a positive, you get negative. So every number between negative 3 and 4 makes this graph negative. Okay, if I plug in 5, 5 minus 4 is positive. 5 plus 3 is positive. If I multiply two positive numbers, I get a positive answer. Okay. Most of the time, these signs will alternate, positive, negative. They do not have to, okay? So don't just get the first one and assume, oh, they always bounce back and forth. They don't always. Most of the time they do. If you ever get the same sign twice in a row, I would double check yourself. It can happen, it just doesn't very often. Now, I look back, I wanted everything less than 0. Is less than 0 positive or negative? Negative. This was the negative section of my graph. So if I want something that'll be less than 0, the number I put in has to be between negative 3 and positive 4. Was there an equal to? No. So my solution is this. Negative 3 to positive 4. Okay, and you can check yourself. If you pick a number, if I put in 0, I get 0, 0, minus 12 is negative 12 less than 0. Yeah, so you can check those. So if you have a quadratic inequality, your answer will be an interval. We have to use this sign line to get it. All right, I know that's kind of new. Have I lost anybody there? Okay, let's do another one. Let's do so we start out pretending it's an equation. If this were an equal to, what would we do first? Slip and slide. Okay, so if I do that, okay, what multiplies to negative 24 and adds to positive 5? 8. Divided by 2. So, x plus 4 to x minus 3. That's my true factored form. Really what I'm trying to find here are the things that make it equal 0. What makes x plus 4 equal 0? Negative 4. What makes 2x minus 3 equal to 0? Flip it. 3. So I need to put my smaller one on the left. So my negative 4 has to go here. My 3 has to go there. You notice when I do this, I always put those on my number line. My test points I just write above because I don't want to accidentally use my test point when I'm writing my final answer. Alright, test point. Smaller than negative 4. Negative 5. In between. And bigger than 3 halves. Okay, we are plugging these in to our factored form right here. And all we care about is positive or negative. So negative 5 plus 4 is negative. 2 times negative 5 minus 3 is negative. If you multiply negative and negative, you get, alright, 0 plus 4 is, 2 times 0 is 0, minus 3 is negative. Positive times negative, you put in a 2. 4 plus 2 is positive. 2 times 2 minus 3, positive, and positive times positive is positive. Does everyone see where I got my positive and negative? So now, for my answer, I have to look back. I wanted greater than or equal to 0. Greater than means positive. So I need this and this because I had 2 positive pieces. Equal to says bracket. So my answer is 2 separate pieces. In interval notation, we do 2 separate intervals. So this piece is coming from negative infinity, stopping when we get to 4, with a bracket, or it could be over here. So the symbol for that is like a capital U. It's a union symbol. So it's saying this piece or this piece. This one starts at 3 halves and goes on forever. So it goes positive. And so that is my answer because there were 2 separate sections that gave me positive. Yes. My bracket covered up my negative. All right. Have I lost anyone? Do you want to do one more of those and then we'll quit for the day? Let's do so first step, slip and slide. X squared minus 11x minus 12, so that factor is x minus 12 plus 1. Divide our 3. Once we get it factored, then we make our sign. What makes x minus 4 equal 0? What makes 3x plus 1 0? Make sure you go the smaller one on the left when you set that up. Okay, test point, smaller than negative 1/3. Negative 1, negative 3, yep, any of those work. In between, maybe 0 bigger than 4, fine. Okay, if I plug in negative 1, negative 1 minus 4 is negative. 3 times negative 1 plus 1 is negative. 2 negatives make a positive. If I put in 0, 0 minus 4 is negative. 3 times 0 plus 1 is positive. Negative and positive is negative. 5 minus 4 is positive. 3 times 5 plus 1 is positive. 2 positives are still positive. Which ones did I want? Greater than 0 would be the positives. No equal to, so these get parentheses. So my answer, negative infinity to negative 1/3, union, because it's more than one piece, 4 to infinity. Tomorrow, I'm going to do some more of these, and we're also going to look at rational ones. So when we have fractions, what do we do? And it's going to be very similar to this strategy. Are there questions? So I'm going to go ahead and give you this homework, and I want you to get started. You've got some time now. But it's not complete. Tomorrow I'm going to add a few more problems to it. So I won't collect it until we have the whole thing, okay? Before you panic, 1 through 10 are matching questions, so. I'm only probably going to add like 3 more questions tomorrow.